Welcome back to AI CodeCast. We love to really get into those classic coding challenges. The ones that seem kind of simple at first, but then, they really have some hidden depths, right? Well, today's problem is a perfect example of that. We're talking about converting a string to a 32-bit signed integer.
Yeah, it's funny. This is a problem that trips up a lot of people, even experienced programmers. And it's
Yeah.
one of those classic interview questions that you see a lot in technical interviews because, it really tests your understanding of how data types work and those edge cases that can really get you and, whether you can code efficiently.
Okay, so let's set the scene here for our listeners.
Yeah.
Imagine you're given a string. It could
Okay.
be something straightforward like, 42.
Right.
Or maybe it's got some white space in there like
Yeah.
neg 42,
Mm-hmm.
or even like something totally messy like 1337 C0D3, or even words and 987. Like, what do you even do with that?
Right, right.
So the challenge here is to write some code that can take that string, whatever it is, and transform it into its numerical equivalent um, as a 32-bit signed integer.
Yeah,
So, I mean, that sounds easy enough, right?
on the surface.
But I'm already sensing there's like a lot more to this than we might think at first. So what are the potential pitfalls here? What are the things that can make this tricky?
Well, one thing is that, computers need to be told very specifically how to interpret information, right?
Right.
So, to us, 42 is obviously a number,
Uh-huh.
but to a computer, it's just a sequence of characters. It's just a string.
Right. So it doesn't like automatically know that those characters mean a number, right?
Exactly. So we got to write code that basically bridges that gap.
Yeah.
It's the translator,
Yeah.
translating that human readable text into something that the computer can actually crunch, do calculations with. And that's where those tricky edge cases come in.
Okay. Like what? Give us an example.
Well, like, how do we handle white space? So should, 42 be treated the same as 42? What about, 42? Is that 42, or is it just 4?
Well, let's see.
So we need to define some rules for how to handle those kinds of variations.
Exactly. Yeah. We need some ground rules.
And then there's, this whole issue of overflow. A 32-bit integer, it can only hold numbers within a certain range.
Right.
So what happens if the string that we're given represents a number that's, way too big or way too small?
Okay, so we've got to think about those boundaries and make sure that our code, doesn't just explode when it hits those.
Yeah.
This is starting to feel a little bit like a logic puzzle.
Yeah, it is, in a way. And there are different approaches we can take to solve it. Let's start by just exploring a really basic, brute force method, just as, a first attempt to get the job done.
Okay, so how would we approach this brute force solution? Like, walk us through the steps.
Okay, so imagine that we're given the string 3042. Right. The first thing we got to do is just ignore that leading white space. So we sort of move through the string character by character until we hit the first non-space character.
Okay, so then we would land on that minus sign.
Exactly, yeah.
Yeah.
So then we'd store that fact, hey, this is a negative number. And then we keep moving through the string, one character at a time. And for each character, we got to check, is this a digit?
Okay, and if it is a digit, then we need to convert it, right?
Yeah.
From its character representation to, its actual numerical value.
Exactly. So if we see the character 4, we need to translate that into the numerical value 4.
Got it.
And then we do the same thing for the 2.
Okay, so we're piecing together the number digit by digit, kind of. This feels very step by step.
Yeah, it is. It's very, very step by step. And then as we build up the number, we need to multiply the existing value by 10 each time we add a new digit. So we start with 0, right?
Yep.
Then we see the 4, so that makes it 4. Then we multiply by 10 to get 40, and then we add the 2, and now we have 42.
And then finally, we would apply that negative sign that we stored earlier, and we end up with negative 42.
Right.
Okay, so that seems to work, but it feels kind of clunky, doesn't it?
Yeah, it's a little clunky. The brute force method, it gets the job done, but it's not very elegant or efficient. There are definitely more streamlined approaches, like using a trick to kind of detect overflow early on.
Right.
Or even using something called a deterministic finite automaton, or a DFA.
DFA. Ooh, that sounds interesting. I think it's time to move beyond brute force and explore some of those more sophisticated solutions.
Yeah, let's do it. Okay, so before we get into those other solutions, I think it's worth, circling back to that overflow issue that we mentioned before.
Right.
Because remember, a 32-bit signed integer, it has limits,
Right. It can only hold numbers within a certain a certain range.
Exactly, yeah. And in a lot of programming languages, if you try to like store a number outside of that range, bad things can happen.
Right.
You might get an error, or the result might just be like totally unpredictable.
So how can we make sure that our code, doesn't blow up when it's dealing with these huge or tiny numbers?
Right. So there's actually a really neat trick for this, and it involves dividing the maximum possible 32-bit integer value by 10.
Okay, that sounds a little cryptic. Why would we do that?
Okay, so think about it this way. Let's say, for the sake of argument, that the maximum 32-bit integer is, roughly 2 billion,
Okay.
right? If our current result is already bigger than 200 million, which is, 2 billion divided by 10,
Right.
then adding any digit other than 0 is going to cause an overflow.
Ah, okay. So it's like we're setting up an early warning system, right?
Exactly.
Like if we hit that 200 million mark, we know we're in dangerous territory.
Exactly. Yeah. So during each step of our conversion process, we would check, is the current result greater than that threshold? And if it is, we know we're about to overflow, and we can handle it appropriately.
That's a really clever way to avoid those nasty errors. It's like putting bumpers on a bowling lane.
Right. Exactly.
So, okay, we've talked about brute force. We've talked about this clever overflow check. Now, I'm really curious about this deterministic finite automaton that you mentioned before. What in the world is a DFA?
Yeah, it sounds kind of complex, but it's actually a pretty intuitive concept once you break it down. Um, imagine a vending machine.
Okay, I'm picturing it. We're ready for a snack.
Right. So each coin that you put into the vending machine, that's like a character in our string.
Okay.
And each coin changes the vending machine's state, right?
Yeah.
It gets you closer to your snack, which, that's the integer that we're trying to get to.
Okay, so the states represent different stages in the conversion process.
Exactly. Yeah. So we might have a start state,
Uh-huh.
a sign state where we've figured out if the number is positive or negative,
Right.
a digit state where we're actually processing the numerical digits,
Yeah.
and maybe an error state, for invalid input.
Right. So just like putting in like the wrong coin into a vending machine might lead to an error.
Exactly.
Like an invalid character in our string would send us to that error state.
That's a great analogy, yeah. And the transitions between those states, those are determined by the characters that we read from the string. So, for example, if we're in the start state and we encounter white space, we just stay put.
But if we encounter a plus or a minus sign, then we move to that sign state.
Exactly. And then if we see a digit, then we transition to the digit state, and we can start, building up our integer value digit by digit.
Like the vending machine just like knows what to do with each coin and it guides us towards that final product.
Yeah.
I like that analogy. This DFA approach feels much more structured than just brute force.
Yeah, it definitely is. It gives us like a very clear framework for handling all those tricky edge cases like white space and signs in a very systematic way.
Yeah, this is really fascinating. It's like we've gone from walking to riding a bike with this DFA approach. It's much smoother, much more efficient.
Like that comparison.
Okay, so before we get too carried away with DFAs, though, there's one more solution that I think we should talk about, and it involves a really powerful tool called regular expressions. Okay, regular expressions. I remember those from my coding adventures. They're super useful for pattern matching, but they can be a little bit cryptic, right? Like at first glance, they look like some kind of secret code.
Right.
So how do they apply to this problem of converting strings to integers?
Well, regular expressions basically give us like a way to define patterns, right? They describe the kind of text that we're looking for. So in this case, we can actually define a pattern that's going to capture the numerical portion of our string, including any leading white space or signs.
So it's like having a specialized tool that can like sift through that string and just pull out the bits that we actually care about.
Exactly, yeah. And the nice thing is that a lot of programming languages, they have built-in functions that work with regular expressions. So we don't even have to write the pattern matching logic ourselves. We can just kind of use those built-in tools.
Right. So we use a regular expression to grab that numerical part of the string, and then what?
Yeah, so once we've isolated that numerical string, then we can just use the language's built-in conversion functions to turn that into an integer, just like we did with the other approaches. And of course we still need to be, mindful of that overflow issue, and and clank the result to that 32-bit integer range, right?
Right, right. So regular expressions kind of give us a concise, efficient way to handle that initial parsing and extraction of the number itself. But
Yeah.
but you mentioned that they can be a little cryptic. Could you maybe give us like an example of what a regular expression might actually look like for this particular problem?
Yeah, sure. So a regular expression for this might look something like s plus plus s.
Okay.
Don't worry too much about the specifics right now, but essentially what this is saying is, look for optional white space represented by that s. Look for an optional sign, that's the s plus a des, and then look for one or more digits, that's the a plus.
Okay. It really is like a secret code kind of to,
Ah,
to unlock that number hidden within the string.
Yeah.
So we've got like three distinct approaches now.
Yeah.
The step-by-step iterative approach, the structured DFA approach, and this powerful regular expression method.
Right.
They each have their own pros and cons, right?
Yeah, absolutely. So the iterative approach, it's very straightforward and it's easy to understand, but it might involve writing a bit more code. The DFA is elegant and systematic, but it takes a little bit more effort to wrap your head around the concept initially.
Right.
And then regular expressions, they're incredibly efficient for pattern matching, but they can be a little bit intimidating for beginners, for sure.
It's like, having different tools in your toolbox.
Yeah.
Right. You wouldn't use a hammer to tighten the screw.
Right, exactly.
You know,
Yeah.
so choosing the best approach kind of depends on the situation and your own comfort level with these techniques.
Yeah, absolutely.
So speaking of comfort levels, let's talk about why this seemingly simple problem is such a favorite in coding interviews.
Yeah, well, I think interviewers love this problem because it's deceptively simple,
Right.
right? It seems easy at first, but it really quickly reveals whether a candidate, truly understands the nuances of data types and edge cases and efficient coding.
It's like a test of your attention to detail and your ability to really think through, all the different possibilities. You can't just jump into coding without, you know, considering those tricky edge cases and potential pitfalls, right?
Exactly, yeah. Interviewers, they want to see how you approach a problem,
Yeah.
how you reason through the different solutions and how you communicate your thought process. It's not just about getting the right answer, it's about, demonstrating your problem-solving skills and your ability to handle complexity.
So for those out there who are, prepping for coding interviews, what are some key takeaways from our deep dive into string to integer conversion? What should they keep in mind as they're, practicing and going into these interviews?
Yeah, I think first and foremost, just understand the problem thoroughly. Don't make any assumptions. Ask clarifying questions if you need to. Think about those edge cases. What if the input string is empty? What if it contains only white space? What if the number is larger than the maximum 32-bit integer? Really think through all of those different possibilities.
Right. Don't just focus on that happy path.
Yeah.
The ideal scenario. Really consider those what if scenarios that could trip you up.
Exactly. And once you have a clear understanding of the problem, then you can start to explore those different approaches that we talked about. Consider the iterative method, consider DFAs, consider regular expressions, weigh the pros and cons of each one. And most importantly, just be able to explain your reasoning to the interviewer, right?
Communication is key.
Yeah, absolutely. Walking the interviewer through your thought process, that can be just as important as writing the code itself.
I totally agree with that. And just remember, practice makes perfect.
Absolutely.
The more you practice these types of problems, the more comfortable you'll become with handling them in that interview setting.
Yeah, for sure.
This has been a fantastic deep dive into string to integer conversion. We've gone from brute force to these elegant solutions. We've explored those nuances of overflow. And we even learned about, those fascinating DFAs and those powerful regular expressions.
Yeah, hopefully our listeners are feeling, a little bit better equipped to tackle this classic coding challenge with confidence.
Absolutely. Thanks for joining us on AI CodeCast. We'll be back tomorrow with another exciting coding challenge. Until then, happy coding.